Today we're going to do the 3-4 Day 1 notes on solving exponential equations. There are two techniques for solving exponential equations algebraically. The first of which is getting the same base on each side. If, however, you cannot get the same base on each side, you are going to either take the log / natural log of both sides, or write in log form. These two things are basically the same thing, taking the log of both sides or writing in log form for the second bullet point. However, some people learn it one way and some learned it a different way, but you get the same answer and it's pretty much the same process. So I could show both of those ways. So starting with the first problem, you are going to get an exponential equation where you have either the same base on each side, or you could possibly get the same base on each side. So if you look at both of these sides, you should see that 16 can be rewritten as 2 to the 4th power. Now, we do this because on the other side, we had 2 to some power. If you can get the same base number, which we just did, you can set the exponents equal to each other. However, on the right-hand side, before we can set these exponents equal to each other, we should distribute first. So you get the negative 8x minus 12. And then on the other side, this stayed the same. So what we are going to do is set the exponents equal to each other and solve for x. And don't be surprised if you get weird answers. A lot of these problems do end up with improper fractions. Notice if you sub that value back in, or you have that option of subbing that value back in, you should get the same thing on each side of the equation. Moving on to the second example, you're going to notice that in the second example, we have a 3 to the 4x plus 100 equaling 2400. So you're going to start off by isolating this exponential piece right here. So we're going to get rid of that 100. Now, this problem is much different because if you notice, we can't take 2300 and raise it, 3 to some power to get that number. So unfortunately with this one, we have to use that second method. Now, I like the idea of writing this in log form. If you remember, this is the base of the log. So what you're going to do is rewrite this as log base 3, and then on the other side of the equals, you put the exponent. You remember the exponent goes on the other side, and then that's going to equal 2300. So you should be able to do the circle of life and get back to where we started, and that's exactly what we see. Now, in order to solve for x, we would have to divide this, by 4. Technically, this is your answer. However, we do want that decimal approximation for this, so this is where you can go to your calculator, and we can find what that equals. Now, again, using your calculator, you're going to see that you can use that if you go to math, and then all the way down, you can find that log base button. Hit enter, and then I can put a 3 here, a 2300 here, and then I can hit enter and then divide that by 4 to get my answer. The second option is if you don't have that log base button, you could just do the log of 2300 divided by the log of 3. and then hit enter, and then divide that quantity by 4, and you get that same answer. Now, when I talked about how in the notes you can take the log of both sides or write in log form, I prefer to write in log form, but you can also, on this problem, at this step right here, so I'll put a little line. At this step right here, some people last year learned to take the log of both sides. So you would have taken the log of the left-hand side and set that equal to the log of the 2300, that right-hand side. And then you use the properties of exponents that say, now that this is an exponent on that left-hand side with a log, you can move that to the front and get 4x times log 3 equaling log 2300. And notice if I were to divide by the log 3, and then I get this quantity right here, which we already saw, and then take that quantity and divide it by 4, notice that you would get the same answer that we got over here, because this piece right here is the same thing as log base 3, 2300. And then when we divide it by 4, we get that same answer. So just showing you either method works. Some of you might have learned it this way last year, where you put a log on each side, which works the same exact way, and you get the same exact answer. So you can decide which you like better. Final problem on this page, and then I think there's one on the back we have to look at, is definitely a very different problem. If you look at this, this reminds me of the trig unit when we asked you guys to take something like sine squared x minus 2 sine x minus 8. And I don't know if you remember that we talked about factoring this, and we wanted to treat this as if it was x squared minus 2x minus 8. It's the same idea here with e. Obviously, this is not sine squared, but you can think of this as x squared minus 2x minus 8, and what we're going to do is factor it. Now, I like to think of this with these problems with e like this, with u substitutions. This is really e to the x squared. Because notice that if I were to multiply those exponents right up here, I would get 2x. So with that being said, if you want to think of this as a u substitution, we would say let u equal to e to the x. And really what we're doing is thinking of this as u squared minus 2u minus 8 equaling 0. Notice I'm replacing a u with this and with this. Now, with that being said, I could go ahead and factor this. Note that this right here would factor very nicely. And I would get u equals -2, u equals 4. However, it's not u. Remember, u is this e to the x. So really, we would have this. Now, again, we haven't solved for x. So just like in problem 2, you have to use this second bullet point. You can either take the log of both sides, or you can write this in log form. I like to write this in log form, but because it's e, I'm going to use natural log this time. Now, this is the base. So I would write this like down here. You don't necessarily need that e, but if that helps you just as you're doing the problems to start, remember the exponent goes on the other side of the equals, and then the -2 would go here. So this is the argument of the log, if that makes sense. And again, this little e doesn't have to be there, but you can put it there. Same thing over here. We would take the natural log and we'd put a little base of e. On the other side of the equals would be the x, and then we'd put 4 here as your argument value. So note circle of life would work on that. Now, to get our decimal approximations, if I were to use my calculator on this, note that if I go to the natural log button and I put in a -2, I'm going to get an error message. That's because that's because this number always has to be greater than 0. We'll get into this more, but even just thinking about graphing, if you guys remember that we have these values in here that have to stay positive and can't equal 0. So every time you get a number inside of the argument that is negative or 0, this will not create a solution. Now, the other side, we're okay. The natural log of 4, oopsie, second. Natural log of 4, if you hit enter, we're all good. We get x is approximately 1.386. So we're almost done. Moving on to the back side of this, there is a word problem. If you need to pause the video and read it over, feel free to do so. For this problem, they talk about 100 animals being released in a game preserve, and they believe that the carrying capacity of the preserve is 1,200 animals. The growth of the herd can be modeled by this equation, where T is measured in months. How long will it take the herd to reach 1/2 of the preserve's carrying capacity? Well, we were told the carrying capacity is 1,200, so 1/2 of 1,200 is going to be 600. So that's the number that we're going to want to fill in, and we're trying to find how long it takes. This is what we want to find. So that means we're solving for T. So what I'm going to do is I'm going to sub in this 600 for the P of T, because that's what we want this to equal. And then we need to solve for T. Now, first thing I see, or I think of this as, is a cross product or cross multiplication. What I can do is I can use the product of one diagonal and set that equal to the product of the other diagonal. Now, in earlier notes, we would use the calculator and we would find the intersection of the left-hand side and the right-hand side. However, you now know the algebraic way of solving for T without having to use your calculator's intersect feature. In order to do this problem, you could distribute the 600, but I believe that creates unnecessary work. I think it's better to divide that out first. And then notice by doing that, we get a 2 over here. Now, from there, we could subtract the 1. And then divide by the 8. Once you get here, this is the same thing as the front of the notes, where we have e to some power equaling 1/8. I'm going to write this in log form. Again, you could take the natural log of both sides, but I'm going to rewrite this with log form. Natural log, my base is e, so that becomes the base of the log. And then remember, over the equals should be this negative 0.1588t, and then the 1/8 goes here. So I should be able to do the circle of life and go back to where I started, and I see that. Now from here, let's get out my calculator. If you want to finish the problem first and then get your calculator, you can. We would just want to divide that then by negative 1.588. So we can do natural log, and then that 1 divided by 8, hit enter, and then divide that by the negative 1588, hit enter, and notice that I get T to be approximately 13 months. Does it say how to round? It does not, so we'll go with 1 decimal point there. All right, so that concludes today's notes. There is a closing problem for you to do. I will create a separate video for question number 9. We were going to do an activity called a jigsaw, but obviously we're not going to. Once you finish question number 9, you can watch the video or check the key for the correct work. And then following that, I want you to download the 3-4 day 1 homework, complete those problems, and then submit that to me by tomorrow morning. Hope you guys are doing well. I really miss you.